So that's the answer to B. Now, when we have a problem that occurs on level ground, so there's no height change, something's not being thrown off of the top of a building, but rather thrown from level ground. When we want to find the total flight time, we just double it. But we don't have symmetry here. The ball takes 0.51 seconds to reach the top, but then it has to fall all the way back down to the ground, which is more than it originally rose up. So in order to find the time it takes to reach the ground, I'm going to take a different approach. I'm going to go back to what I know. Delta y is negative 30 meters. V initial y is 5.1. AY is negative 10. So the same set of knowns that I had before, but I'm not using the idea that V final y is 0, because that's actually not the case here. If I'm looking at the whole trip, right, this is the entire and this time I'm going to use this equation. And I actually know everything in this equation except for time, which is what I'm trying to solve for. I will end up with a quadratic, which means I'll have to use the quadratic formula to be able to solve it. Let's plug in what we know. One half times A is negative 5 times time squared. So I end up with the following quadratic. I'm going to take the units out just to make it easier. 5t squared plus 5.1 plus 30. You can use a quad program. Oh, this should have a t in there. You can use a quad program on your calculator. That's what I'm going to do. You can also use the quadratic formula. But when I solve this, I end up with time giving me two values. I get 3.01 seconds, or I get the ever mysterious negative 1.99 seconds. So really what you're doing is you're solving a parabolic problem, which asks, if we look on our graph, our picture up here, actually let's go with orange. It's asking me, when am I at this height? Oops. When am I somewhere along this orange line? Well, if you think about it mathematically, that occurs right here, right? That's when you land. But you could also say it actually also occurs if I were to extend this back. But that's not a real time. That never happened. We were never back at this point. That would be that negative 1.99 second time. So we're going to ignore that. We don't need that. It's irrelevant. It doesn't mean anything. So when I go back to my actual data, don't need this time. What I'm looking for is 3.01 seconds. So that's the answer for C. Lastly, well, not lastly, D.